Hello class, welcome to our next chapter, chapter 6. This chapter is going to focus on rational functions and rational expressions. So I wrote up here just a definition just to refresh your memory of what a rational number is to give you a better idea. And so a rational number is any number that can be written as a fraction. So any fraction obviously will do. Integers would do, because you can always put those over 1. Any repeating decimal, decimals that end, so for instance, 0.4 can be written as 4/10, which would reduce down to 2/5, which is clearly a fraction. So that's the idea. Most of the time, we will end up with a variable in the denominator, which makes this a little bit of a trickier chapter. The entire chapter has to do with fractions. So almost every question, no, let me take that back. Literally every question in this chapter will be a fraction. And 98% of them will have a variable in the denominator. So at first it's gonna look a little tricky, and we just need to get over that hurdle. And I know that fractions give students a lot of anxiety in some cases, and so I would encourage you to just kind of go slow and just watch each particular lesson really carefully, practice those lessons before moving on. So, our first example is going to be to find where the expression is undefined. So the very first part of this lesson talks about what type of x value would create a problem for this particular fraction. Well, if you recall, the denominator of any fraction cannot be equal to 0. You cannot have, if you think about what a fraction means, all right, so total side comment to this. If you think about what a fraction means, I have some type of an object, a cookie, a pizza, what have you, and I have shaded one of those pieces out of a possible 4 pieces. So when you very first learn about fractions, you learn to write it something like this. 1 piece out of 4 pieces. So if you have a fraction that looks like this, what does that mean? How do you, if you think about it in the context of an actual object, like a cookie or a pizza or something round like that, how do you have 5 pieces of nothing? How would you define that? How would you draw a picture to represent that? So the bottom of our fraction cannot be 0 because it just doesn't make sense with what we understand fractions to be, part of a whole. So what value of x would make that denominator 0? Well, if you don't see it right away, what we're going to do is we're just going to set it equal. Set that denominator equal to 0, and we're going to solve it for x. So subtract 2, and anytime x is equal to -2, if you substitute that in, you would get 0 for the bottom. So we would say this is the point in which it is undefined. There's lots of ways to write this. You can write that x equals -2 is where it's undefined. You can say x can be anything but -2. And the MyMathLab problems might kind of toggle between what type of answers they expect you to put. So just be really careful on how the instructions are written. All right, let's make this a little bit harder. Let's say find the expression, or find the value in which it's undefined. We'll put 4 in the top, and we'll say x squared plus 5x minus 14. All right, well now what do? Now it's not just something that is x to the first power that you can easily set that equal to 0. So now our steps are going to go back to that section from 5.7. So all of chapter 5 is going to be applied here in chapter 6. We need to set this equal to 0. We should anticipate two answers. We are going to factor, and then we are going to set each factor equal to 0 and solve. So if it is x squared, you can anticipate that you're going to have two answers that are going to be undefined. So my factors here, we have two numbers that multiply to -14 and add up to 5. So we've got a +7 and a -2. If I set each of those equal to 0, I'm going to subtract 7 from both sides. Subtract 7, subtract 7. So there's one of the answers. I'm going to add 2, and there's the other one. So it literally is the same process we used in section 5.7. All right, just one last note on this. And I touched on this on the first one. Like my example on the first one did have x in the numerator. So I just want to make sure I didn't make that clear originally. Let's just throw something up here like this. Okay. The top can be, the numerator, the top of your fraction can be 0. I can have a pizza shaded, like cut into 4 pieces, and none of them are shaded. And so I can have something that's sliced into 4, and I didn't shade any of them. So the numerator can be 0. So -1 is not what we're looking for. We don't want to focus on the numerator at all. We just want to focus on the denominator. Where is the bottom of the fraction equal to 0? And just in case maybe you tried this one on your own, and then we can use the patterns we've used before, and those are the two values that x cannot be. All right, so that's part of your lesson in 6.1. The other part is reducing, otherwise known as simplifying. And I think that is even the title, if I'm not mistaken. It's called Simplifying Rational Expressions. So, in other words, how do you reduce these fractions? We're going to learn to reduce. So let's review what it means to reduce. If you have 18 over 24, you look for common factors. What numbers go into both of those numbers? And maybe you can look at this and go, well, gosh, this is 6 times 3, and this is 6 times 4. And anytime we have a factor over itself, that value is equal to 1. So we can cross that out, and that reduces down to 3/4. Maybe somebody else approaches that same fraction, and they think of it like, gosh, well, 2 goes into 18 9 times, 2 goes into 24 12 times. So now they've got it down to here. And they kind of break it down a little piece at a time. Between 9 and 12, I know that 3 goes into 9. I go 3 goes into 12. And now I no longer have any common factors. So regardless of which way your approach is, you end up with the same thing at the end. This is the idea we're going to look at today. But our fractions are going to be a lot more complicated. So here's our first example, and our instructions throughout the rest of this section is to simplify. So if I forget or intentionally don't write that over and over and over again, so here's my example A. And here's my example B, and I'll just kind of write a few of these. Some of these come straight from your textbook. Others I probably just made up on the fly at some point. And then D. And we have a few more complicated ones after this. But this will get us started. So again, anytime you feel like pausing, trying it on your own, maybe you already have some familiarity with this topic, so you do whatever works well for you. All right, so we're looking for those common factors. So between 6 and 42, we're going to divide those numbers. 6 goes into itself, 6 goes into 42, so that goes once. 6 goes into 42 7 times, so we have something that looks like that. Then we're going to subtract our exponents. So if we have x to the third over x squared, kind of side comment, remember from chapter 4, those cancel, you end up with x to the first power in the numerator. Now, I'm not overly familiar with MyMathLab, but I know that it is kind of challenging sometimes to type those answers into the program. So I looked ahead on this. Here's the way they want you to type it in. So you have this 1/7 that is the coefficient, and then x will be here in the middle. It's technically in the numerator, but they probably won't even have you put a 1 right there. So if you're getting a little confused on that, just work with the computer program till you figure out how to type that. These two things are equivalent. So if we were in the classroom together and you wrote your answer like this, I would give you 10 out of 10, 100%. But the computer will probably only take that way. All right, B. Now we're getting a little bit more complicated because now we have this addition sign. So we have a 2-term polynomial or a binomial. So what we need to do here is we need to factor out any type of GCF that we see. So what can I pull out front of 3 and 12, which is a 3? Since I only have a variable in the first term, I can't pull a b out of the back. So what I'm left with here is b plus 4. And then I have a 15 in the denominator. Now I can look and see if I have any common factors here. 3 divides into itself once, 3 goes into 15 5 times, and so this would be equal to b plus 4 over 5. C? C is a big, like I would circle C, make big stars around it, indicate that, highlight it. Here's what students tend to do. They see the 7 there, they see the 7 there, and they cross it out. You can't do that because there's not a 7 in front of the x. So you need to look for that GCF. And there is no GCF here. There is no number you can pull out front. And you're not allowed just to slash those numbers there in the back. It's not equivalent. It's not sound mathematical practice. So this does not reduce. That is the final answer. It is trig. It is one of those things where you consider it to be a prime, like we looked at back in chapter 5. You can't do anything. It's like trying to reduce 1/2. There's no more factors that divide into either of those numbers. So you're done. All right, it just stays the same. Let's look at D. We need to look for the GCF in the numerator, the GCF in the denominator, and then we'll go from there. So I can pull a 5 out of the numerator. I'm left with x plus 3. I can pull a 4 out of the denominator. I'm left with x plus 3. This entire factor is now going to cancel with that entire factor, and we end up with 5/4. We're going to build on this idea here where the common factors are now going to be the binomials. So let me erase real quick. And we'll add a little bit of complexity to our problems. So if you want to continue to use that lettering, we were on E. And then I've got this one. And at any time, again, I would encourage you to just stop and try. If you need to go back and review any of these factoring types, here's one specifically for you to try. Oops, I always get messed up when I don't use X. But of course the book and the practice use all sorts of letters. Okay, so there's one for you to try when you're ready. Look for the GCF. So you just, even sometimes students get so overwhelmed by how complicated they look and you're not used to fractions in the first place. So sometimes I have even suggested to students like, hey, just take a piece of paper and cover the, like whatever fraction part you're not looking at, just cover it up so it's not overwhelming and just concentrate on the top or concentrate on the bottom. So that may or may not help you. So I'm going to pull out the GCF for this numerator. I can pull out a 6 and an x. So I'm left with 6x. And what is on the inside of that fraction, it looks like 3x plus 1. On the bottom, between 6 and 15, the biggest number that can pull out front is a 3. And then both of these have x, so I can pull out an x. And what I'm left with inside, 3 goes into 6 2 times, and then I'm left with an x. 3 goes into 15 5 times. So in this particular example, what's left in those parentheses don't match, but, and again, color can help. I can drop out an x, and 3 divides into 6 twice. So when I write my final answer, I would have 2 parentheses, 3x plus 1 over 2x plus 5. If we were in person and you left your answer like that, that would be 100% acceptable. There's a chance in a My Math Lab situation, they may want you to go and multiply that back through. I can't say whether or not you need to do that. That 2 and that 2 cannot be canceled because this 2 is out front of this parenthesis and this 2 right here is just the coefficient for the x term. So don't go crazy and cross things out where you shouldn't. All right, factor the numerator, factor the denominator, 2 separate pieces. So x plus 1, x plus 2. And this is that difference of 2 perfect squares, x plus 2, x minus 2. Notice how the way I factored it, these kind of ended up diagonal, doesn't matter. So we can cross those out. So my final answer here is x plus 1 over x minus 2. Are the parentheses necessary? Not technically. I like to add them because I want to make sure that no student accidentally crosses out those x's and writes down that the answer is -1/2. So these guys, they cannot be separated. They are married. They go together as a quantity. So that's why I like to include the parentheses. Go ahead and try this one if you haven't already. The numerator is going to factor two numbers that multiply to 6 and add up to 5, and notice how everything is positive. And then on the bottom, you have once again the difference of two perfect squares. So the a plus 3's cancel, and so you end up with a plus 2 over a minus 3. All right, that is the gist of this lesson. There's just one more little one that I want to make sure that you understand, and it's when your factors are opposite, meaning that it's almost going to work out perfectly, but there's just one little trick that you have to deal with. So same instructions, we're going to simplify. What happens if we have something that looks like this? Okay. So in the numerator, there is no GCF. You might want to just put parentheses around that so you know that that is a quantity. The denominator here has a GCF of 2. Now, I'm going to put the answer right here real quick because I want to show you something. If I pull that 2 out, I end up with 4 minus x. All right, so here I have x minus 4, and here I have 4 minus x. Notice that it's the x here that's negative, 4 is positive, and the reverse is true here. X has a positive 1 as a coefficient, and the 4 is negative. So these are considered to be opposite factors. So what I really want is I want this to switch. One way to make that work is instead of pulling out a positive 2, go ahead and divide through by a negative 2. And when you do that, negative 2 goes into positive 8 negative 4 times. And negative 2 goes into negative 2 positive 1 times. And then we're just going to rewrite this. So instead of a negative 4 and a positive x, we are going to write this as negative 2 parentheses x minus 4. And it was a little just manipulation trick to make these factors match up. And so, again, I pulled the negative out here, so it reversed the signs inside the parenthesis, so I could switch the order of how I wrote it. And now, x minus 4 matches with x minus 4. This might be the first time that I didn't end up with a numerator. Don't just accidentally write the answer as negative 2. If negative 2 was in the denominator at the beginning, it's still in the denominator here. So you need some type of a placeholder. So you need 1 over negative 2. You could also write that with the negative out in front of that fraction, and it doesn't change the value. So you guys try one like this. Just go through the motions and practice. And this is our last example for this lesson. All right, now, some people might have even pulled a negative out of the numerator because maybe you don't like to see the n in the back, but I'm guessing you kept the numerator like this, and you pulled not a positive 5, but you pulled a negative 5 out, which would make that a negative n and a positive 3. And so that would enable me to write it in reverse. And so these would be common factors. And my final answer would be negative 1/5. And again, I can write it with the negative in the numerator, the negative out front of the fraction, or the negative assigned to the denominator. And there is no difference between the value of those three fractions. As long as you just have one negative sign, It doesn't matter if it's in the top, out front, or in the bottom, which I think sometimes is a nice reminder for you guys. So, section 6.1, that's it. You're going to factor and kind of slice those and reduce those, and I wish you success. So, enjoy.